Chapter 3 is where we are. I'm skipping 3.1. There's nothing really of value in 3.1, and we're popping up to 3.2. So the first thing to do, 3.2, we need is a reminder of how to create what's called a Cartesian coordinate system. So geometry experienced people might vaguely remember there was a guy named Descartes, French guy, philosopher.
I know that dude.
Put algebra and geometry together is what he did. But since his name was DES and then CARTES, they named this after him. So this is called a Cartesian coordinate system, named after René Descartes from 1800, 1700, something like that. But if I'm asking you to draw me a Cartesian coordinate system, does anybody remember any of the aspects of that? There's a gesture out there that I acknowledge that we've got something that goes like this and that. That's part of getting the system set up. Yeah, which one's which?
X is the right and
Yeah, this is called the x-axis. This is called the y-axis. In the world of life, but not appearing in our class this year, there's also a z-axis. Does anybody know where the z-axis would be?
It's like, from the picture, it's like coming towards us.
Yeah, it would have to come out of the board at you and make like 3D graphing. We're not going to do that at all. But that's true. There's an x-axis, there's a y-axis. There's a few other names that we're going to hunt down.
Origin?
There's an origin. Where's the origin?
Quadrants are there too.
It's right where they cross. So that single spot where the axes, the plural of axis is axes. So where the axes touch, that's where the origin is. Somebody said quadrants. All four of these zones are called quadrants. Where's quadrant one?
One is corner, top right corner.
Top right. And what do they do unusual about the
It
names?
goes
It goes counterclockwise, that's true. But in terms of the numbering system, it's Roman numerals. So that's one, that's two, that's three, that's four. I'll write the word quadrant on here once because I'm too lazy to write the word quadrant on there 4 times. But that's what you need to know. That's when somebody's talking about drawing a coordinate system, they're talking about that. You're going to need to have graph paper this chapter, as I had advertised a couple days ago. Ordered pairs is another big thing we're going to see a bunch of today and through the chapter and through the year. What do I mean by an ordered pair?
like the stuff that's behind you.
Yeah, the stuff that's behind me, these parentheses with commas sorts of things. So this first number is called the what? X. X what? It's a long C word. X coordinate.
Another one combined.
And the other one is called the Y coordinate. And what those are is basically like your recipe to know where you're going to go to find a certain spot on the board. So if I want to find that spot on the board, it takes a pair of numbers to get to that spot. Kind of like playing Battleship in your childhood. If you played Battleship in your childhood, they need to say like G6, you know, and those two numbers, those two, one of them's a letter, but those two coordinates send you to a space. Maybe geography, you've done stuff with latitude, longitude. Somebody gives you the latitude, longitude numbers. You can find the spot on the map. Somebody gives you the X and Y coordinates, you can find the spot on the coordinate system. Where does that first number send you?
Right or left?
Right or left? That sends you right if the number is positive, or left, obviously, if it's negative. Where does the Y coordinate then go?
Up or down?
Up or down? Up would be for positives, down would be for negatives. So the first bit of homework is going to ask you to plot the points. The homework will be on 111. When the homework asks you to plot the points, all you're going to do is do a clustering of points that look like the stars in the sky, but you don't play connect the dots. Okay? If it just says plot some points, just scatter them around. They look like whatever they look like. So over here, I'm going to plot 2, 4, 6, 8, 9 points, but I'm not going to try to connect the dots. I'm just going to plot the points. I drew you some very primitive looking graph paper, so anytime you're going to plot points or graph anything, you need to do an x-axis, you need to do a y-axis, and then the squares are there, let them be your guide. I would suggest a ruler if you're messy, because my experience is that some people, their X and Y axes look sort of like that on their paper, and that's just not visually very appealing. So if you can't draw a straight line, grab yourself a ruler or something, do a nice straight x-axis, y-axis. Where will one, let's try this question. Quadrant 1, the top right. Which of these letters would end up in quadrant 1?
A.
A. Where exactly will A be? Right 1, up 2. You want to land on the corner of a square, and you don't count the origin as anything. The origin is like the 0 squat. So we're over 1 square, up 2 squares, we'll be on the corner of a square. As long as I stick to whole numbers, you want to stick to corners of squares. Which quadrant would B be in? 2. Where am I headed there?
Left 3 up.
Left 3, up 4. So there's B, there's A. On a quiz or a homework, if they do letters in the book or on the quiz, it's helpful to put letters on the points so we know who's who. Check. Where would C go?
Left 2, down 3.
Left 2, down 3. So there's C, D,
Right 3 down 4.
right 3, down 4. So we've got 1 in each quadrant to this point. Anybody a question about that? This is not in a quadrant. The lines themselves don't count as quadrants. The quadrants are only like the interior of the space. The lines themselves are just their own thing. But 0, 2 is just going to go
Up 2.
up 2. So there's E. If 0, 2 went up 2, then
Down
0,
3.
negative 3 is down 3. Negative 3, 0 is left 3. Let me make something a positive because I don't want to do 2 of the same essential thing. That's going to go right 4. And then where's this? Origin. It's right at the origin. You've been there, done that. If that seems familiar, it's because that started in 7th grade at the latest, maybe even earlier than 7th grade. You've been there, done that, but it's a good reminder maybe. Anybody need any kind of reminder of how to plot the points? Because that's a super crucial fundamental skill for objective. Okay, there? So I'll stroll to my left and leave my cameraman to adjust me out. Okay, so you now have ability to do homework questions up to 8. Okay, up to 8, they're going to be just a bunch of scattered dots that look like what we did over there. Then we kick in this idea. If an equation has 2 variables, which they're going to in this homework pretty much all the time, all of the solutions are going to be ordered pairs. So if I give you one equation, 2 variables, I want answers, ordered pairs is the way to go. So if I say x plus y is 5, what's one ordered pair that can work? 2, 3 can work. 3, 2 if you reverse it can work. They're called ordered pairs because the order matters. 2, 3 is in a different spot than 3, 2. Because this went right 2, but this went right 3. This went up 3, but that went up 2. Order matters, they're in different places. But that's 2 ordered pairs. Go again. 4, 1. 1, 4. 5, 0. 0, 5. Could you do one that involved a negative number? Negative 6. That would have to be 11 to get back up to positive 5. So negative 6, 11 would be a thing. Can anybody do one that has a fraction or decimal in it?
Negative 5.5 plus 12.5.
Plus
12.5.
let's do 2 positive decimal fraction. 1.5 and
I said
4.5? 4.5 and 0.5, that works. If I asked you for all of the solutions, what would you think about that project?
You're very mean.
I'm a very cruel man, is exactly what I was thinking. Great minds think alike. Why would I be a very, very cruel man if I asked you to write all of the answers to that?
Sounds like infinite.
It's an infinite amount, okay? That could never, ever possibly end. Maybe that's something Satan does in hell when you arrive and don't like math. Maybe he assigns you something like that to do for all eternity. I don't know how that'll work. But there'd be no end to this. There would be no stop to that. It would go forever. The only way you can show all of the answers is to graph. Some students like graphing. Some students don't like graphing. Some students it grows on you over time. Some students it doesn't. I don't know where you are. But I can tell you it's a necessary tool in the sense that if you're told to show all of the answers, the only realistic way you can do that is to graph something. There's just no avoiding that. But if I start to do this, 2, 3 is over 2 up 3. 3, 2 over 3 up 2. 4, 1 would be roughly there. 1, 4 is roughly there. 5, 0 is here. 0, 5 is there. Negative 6, 11 would be probably up there somewhere. Someone's calling my phone. This is unheard of.
Lucy, you got scared, didn't you? I saw you went.
Yeah. That's silly. That's a nonsense call. They can just listen to that ring forever and I don't care. 4.5.5, where is that?
Over 4 and a half.
Okay, so we go over 4.5 squares, up a half. If we had time to do this, and if I had good drawing skills at the beginning, what's going to happen eventually?
It's going to make a line.
It's going to make a line. Okay, point by point by point, you'd end up gradually, if you had all of eternity, you would continue to find all sorts of points that would go all through the board, back and forth, and back and forth, and back and forth. If it works, it's going to go on the line. And if a point is found on this line, that means it's going to work. Okay, it goes in hand, but sooner or later you end up with a straight line to this. Is every graph in the universe a straight line? No. But to start off our homework today, some of them are going to be straight lines. But we're going to graph some other stuff today as well. But the only way we have to show all of the answers is we graph it. Why is mine not exactly straight? Why did my line go not exactly straight? I've got a little bit of wobble to it, I think.
You're not like a robot?
Yeah, I'm not a robot. Where's my flaw? Or flaws? What are potential flaws that make us go a little crooked because I'm human on the board?
No rollers.
I don't have a ruler. So is my x-axis and is my y-axis completely straight?
Nah.
Probably not. Although my x-axis is pretty good, my y-axis has a little bit of wobble. You should be able to solve that on your homework. Your homework should be better lines than I can ever do on the board because you can use a ruler on your paper. What's an even bigger problem on my board that I can't avoid, but you do on your homework, and your lines will be better than mine on the board? Graph paper. Because how do I have a flawed bit of homemade graph paper on this right now?
The points aren't like exactly equally apart.
Yeah, these aren't the same space apart. This one's pretty wide. That one's way narrower. That one's kind of medium size. That one's probably about like what the first one was. My marks are like close-ish, but not really. Okay. What you don't want to do on your homework ever is once you draw your y and x axis, you never want to start making these marks that I make on the board. And I've sometimes had people think that's what they're supposed to do because it's what I do. I do it because I have to. I don't have blackboard graph paper. Okay? You don't need to make the lines on your graph paper because there's lines on the graph paper. That's why you're using the graph paper. So you don't need to put any of these weird hash marks on there. Just like over there, I wasn't using hash marks. I used homemade graph paper for a second. But your squares are spaced perfectly, so your lines should line up perfectly, much better than I can duplicate on the board. Question about that? What we did here is fine. Usually you get your information organized in a little bit different way. Did I need to do 8 ordered pairs before I would have been able to see that line? No. How many would I have needed to make a line?
Like 2.
2? Why would I recommend you do 3?
Just to like make sure.
just to check, because any 2 points could make a line. So if you do 2 points and you're like, oh, that makes a line, well, congratulations. Any 2 points you put anywhere in the universe, you could connect them with a line. But if you have 3 points and they all line up, that's a sign you're right. Because if you're wrong, you wouldn't get like this, you'd get 3 points that made like a triangle shape. Okay, so if you do 3 points and it's triangular, fail. If you get 3 points and they line up, you're on the right track. Does anybody remember from your days gone by a little structure, an organizational system you used to like get these 3 points going?
Slope and intercept. What's the slope and the intercept?
We could, but we don't know about slopes and intercepts yet, other than PSAT review, we bumped into that. So I'd rather not get into the slopes and the intercepts and stuff with people yet. That also won't help us at all here, because this is a whole different family in flight. Anybody have a memory of, other than slopes and intercepts, a way that we can like organize some ordered pairs? Other than just sit here and brainstorm them and make them up, which work, but it's not necessarily the way to go. No memories? Most of the time in Algebra 1, you spent making like XY tables. So you'd have a column for X's, you'd have a column for Y's, you'd get ourselves organized. You could pick any numbers you'd want to pick. If it's Y equals, would you rather pick some X's that would lead you to the Y's, or would you rather pick Y's that would lead you to the X's? Which way would make your work easier? Pick the X's. So if we have X's, we just pick an X, take that times 2, add 5, and that could give us a Y. You could pick literally any number in the world you'd want to pick. But I wouldn't probably pick like 50, because then what would you have to do on your graph paper?
Make a scale for 50.
Make a scale to go to the right 50 squares, and your graph paper might not even be that wide. So we'd like to pick some easy numbers to use, but anything that's Y equals, pick some numbers for X, do 3 of them to start. What would be always your favorite number to do math with since kindergarten? 0, 1, and then it's debatable whether some people might do 2 or some people might do -1. It depends on your comfort level with negative numbers. Some people are scared of those, so I'll go 0, 1, 2. So we just try them out. 2 times 0, add 5, is 5. 2 times 1, add 5, 7. 2 times 2, add 5, 9. And now what we're doing in our imagination, we're viewing these all as ordered pairs, but I'm probably not going to write the parenthesis commas ever again. I just want to make sure we're clear on this table is an XY ordered pair set of stuff. Question about how we built the table of 3? Then go. 0, 5. Where is 0, 5? Up 5. I'm eventually going to have to go up how many? 9. So I'm going to change where my x-axis is to just make my life a little bit more spacious. So up 5 is there. 1, 7.
Right 1 up 7.
Right 1 up 7 is there. 2, 9.
Right 2 up 9.
Right 2 up 9 is there. And that's pretty much a line. I'm a little wobbly, but life goes on. Connect those with a line. If I had graph paper, I'd be much better at it. Something about that. Use every square as 1 unless you have a reason not to. If this table were counting 50, 70, 90, then I'd relabel this to be counting by tens or something. But for most of your homework and the quizzes we'll do, just do each square as 1. It should be fine. Okay, this, I'll tell you, will not be a line. Anybody a thought on something different about this that's causing it not to be linear? It is going to be a U shape. We've seen these in Algebra 1. Anybody remember what caused it to go U shape, not linear?
The square.
The square. Anything that's squared is going to be U shape. We'll get absolute values in this chapter, but not today. Does anybody remember what absolute values did shape-wise? Coming attractions. Again, it's y equals. So again, when we make our xy table, we would like to make our choices be for x. Our favorite numbers are probably going to be
0 and 1.
0, 1, and 2. We're always going to need at least 3, and then just see where we are. So 0 squared and add 4. 1 squared and add 4. 2 squared and add 4. 8. And I'm again going to move my x-axis because I'm needing to go up to 8. So let me just give myself a little more room to operate. 0, 4. Up 4. 1, 5.
Right 1 up 5.
Over 1 up 5. 2, 8.
Right 2 up 8.
Right 2 up 8. Those do not make a line. As we already advertised, we're going to get a U. Maybe you didn't know you were going to get a U, but trust me, everything with squared is going to be some kind of U. So we need to figure out how to get some more points here to see a little bit more of a U shape, because I'm seeing half of a U shape. And the answer is pick a negative. So your best negative number to use is probably -1 to keep life simple. What's -1 times -1? +1 adds 4. It's also 5. So we're going to head left 1, up 5. This graph is going to have a thing called symmetry. That means the two sides are the same, like your face is symmetric. You draw a line down your face, both sides are basically the same. Your hand is not symmetric because like your thumb and your pinky, you're not the same thing. Some things are symmetric, some things aren't. But this is going to have symmetry. Any of the U-shape, the squareds, they're going to have symmetry to them. But I would do one more just to be safe. Let's do -2. -2 times -2? 4, add 4, 8. So when we're left 2, we're up 8. That's definitely starting to be a U shape. Could you do more points? Sure. But if we wanted to plug in 3's, any of the 3's squared that added 4, 13. Now we're over 3, we're up 13. They're going to get big fast. You know, you plug in 10,
That's 100.
you're up to 104. Okay, maybe you don't want to do that. Question about that one? This has a switch. What did I switch? I switched X and Y. Still a U shape, do you think?
Yes.
Yes. Anything squared will be U-shaped. Anybody have a guess what's going to happen?
It's going to be sideways.
Upside down or sideways would be two reasonable guesses, and we'll see. So when we go to build our table, X, Y, am I off to a good or bad start?
Bad start.
Bad start. Okay, if it's X equals, you don't want to put the numbers in for X and then have to do opposites. Especially because what's the opposite of squaring?
Rooting.
Rooted. That wouldn't be wrong, but it would be unwise. Okay, that would become difficult. We're going to want to do 0, 1, 2 in Y life. So 0 squared subtracts 1.
-1.
1 squared subtracts 1.
0.
And then 2 squared subtracts 1.
3.
3. Where is -1, 0?
Left 1.
Left 1. Where is 0, 1?
Up 1.
Up 1. Where is 3, 2? Over 3, up 2. So that I'm not convinced yet that I know what I have. And so again, our solution is do some more numbers, but do some
Negative.
negatives. So if I go -1 here, is that a good or bad idea? Bad, because we were picking for y. So -1 times -1,
1.
subtracts 1, minus 1,
0.
0. Where is that location?
Just not one.
It is down 1. And I'm starting to maybe see a little bit U-ishness, but let's go once more. -2 times -2, 4, minus 1, 3. So 3, -2. Do you see a U? Yep. Do you see some nice symmetry that it should always have in the U's? Yeah. So play some connect the dots. If they use the word graph, they want you to play connect the dots. If they use the word plot, they just want the dots just scattered around. Don't play connect the dots. Question about any of that? I have one more little thing to do. I'm just going to go that way, and then we don't have to move anything. So So the last little bit of homework is going to tell you to plot some points. I don't know, yell a number.
7, 14, 2, 9, 8, 1.
And then it'll ask you to find the domain and the range. The domain is just all of the x's. The range is all of the y's. Alphabetical order can help you remember who is who. X comes before Y in the alphabet. D for domain comes before R for range in the alphabet. We're good on that. They'll have to say more than plot though. They might have to say like plot the points, connect them, and then find domain and range. So my main friend picked a 14.
Look at that case.
Oh, I think he meant 4. Oops. I
Yeah.
slipped. So 7, 4, 5, 6, 7. 1, 2, 3, 4. Something about there. 2, 9. Something like that. 8, 1. Connect them. So mission 1 accomplished. We plotted stuff earlier in the period, but they wanted us to play connectors. Question about what we did there. When they want you to find the domain, the first point started here. The last farthest right point ended there. So this is the domain. There it is. If I wanted to write that a different way, when we did this sort of graphy graph last chapter, what did that look like if I wanted to write that not with a graph but with a different way?
X greater than or equal to or less than or equal to, you choose
Yeah. Started with,
the lower number.
which was 2, and the highest x I hit was 8. So if you already have a graph, you could just shade the domain on the x-axis, but if they ask you to describe it somehow, maybe they're after that. I don't know, we'll have to look at the homework and see. For the range we check the y-axis, what's the lowest end of the range? 1. What's the highest end of the range? 9. So we could do something like this. There's the range. The range would be a y answer that I need to stay between. I'm not. That's domain and range. That's not earth-shaking, I don't think. It's just a word. That's it for me. So let me look at homework page with you, a little description. So if you want to leave through 111 with me, feel free. On page 111, the work we're doing here is 2 to 20, we're just doing the evens. So 2, 4, 6, 8 is plotting points. Do or don't connect the dots? Don't. Plot the points, just make the dots. Some of them are going to make lines and triangles and stuff, but they're not looking for you to connect the dots up to 8. From 10 to 20, they want you to determine whether something is a solution or not. I didn't practice that at all. So let's go x plus y equals 7. If I said 2, 5, you would say
Yeah.
yes, because
It adds to 7.
that adds to 7. If I said 2, 6, you'd say no, because it didn't add to 7. So as you work your way from 10 to 20, it's just yeses and nos, whether they work or not. Small modification too to our ordered pair information. It's always x, y. You're used to that. What if the problem had a's and b's?
Same thing.
It's AB.
It would be a, b. You'd always just go in
Order for order.
alphabetical order. So if they decide to do m's and n's, The first one is the M coordinate, the second one is the N coordinate, because I do see them messing around with letters. 21 to 29, we start the graph. Okay, so for 21 to 29, we're going to do all of them now. 21 to 37 is an all zone. 21 to 29 says graph these and you should have a straight line. So what I'd like to see is a table of 3, a graph paper that has 3 dots on it, and then a nice straight line. 21 to 29 are going to do what this one did. 30 to 35, it still says graph, and it says you should obtain a curve like the one in example 3, by which they mean it's U-shapes. These are called parabolas. So you should get a parabola, a U-shape. On that group, I'm going to ask you to do exactly what I did. A table of 5 to create 5 dots. Hopefully you have the symmetry going, and make a U. If it's Y equals, it'll be a normal U. If it's X equals, it's going to like lay down and take a nap. It's sideways was the answer for that one. 36, 7 will be like what I finished with. They'll give you 3 points or more. They'll ask you to like play connect the dots, get kind of a shape going. 36 will be a triangle. 37 is going to be a circle. And then they want you to shade in the domain and range, and they want you to also describe the domain and range. So they want them both. They want the picture answer, and they want this like less than sandwich sort of answer, and that takes us to 37, and that's it. Anybody 111 see anything that you're like, I don't know what to do? Questions?